So let me see. We are live. So, Professor, I'm going to introduce the talk in Portuguese a little bit, and then, okay. Boa noite, pessoal. Sejam todos bem-vindos. Já tem uma galerinha aqui com a gente. Então, essa noite, a gente tem a honra de ter aqui o professor Steven Reis, que vai falar para a gente, dar um background aí, apresentar um pouco dessa discussão que envolve behaviorismo, linguagem, vai dar uma, né, fazer um apanhado aí das últimas décadas, né, nessa área de pesquisa. E então, essa é o nosso grande convidado aqui da noite. Só para apresentar, nós somos o Incógnitos, um grupo de estudos de linguagem e cognição da Universidade de Campinas, Universidade Estadual de Campinas, e a gente tem várias outras atividades, né? Reuniões abertas, palestras, os nossos seminários, né? Que a gente realiza e ficam algumas coisas disponíveis aqui no nosso canal do YouTube. Então, por favor, assistam aí depois também. Inclusive, o nosso próximo seminário vai ser agora em setembro, final de setembro. Então, participem também, já fazendo aí o merchan. So let's do this. Thank you so much, Professor, for being here with us tonight. I'm going to read your mini bio, okay? So Professor Steven is a professor of psychology at the University of Nevada, Reno. He's authored 48 books, including Get Out of Your Mind and Into Your Life, which reached number 20 on Amazon's bestseller list, and A Liberated Mind, which explains why psychological flexibility helps us navigate the world. Methods he has developed are distributed worldwide by the World Health Organization and other major agencies, and he is among the most cited psychologists in the world. So thank you so much, Professor Steven, for being here with us tonight. I'm going to remove us from the screen so then I can put on your presentation. And thank you so much. So people, I'm going to remove us from the screen and we'll be right back.
All right, very good. Well, thank you for the introduction, and I'm very pleased to be able to speak to my friends in Brazil. You may not know, but I was telling the group, my wife is a gaúcha from Caxias do Sul and Rio Grande do Sul. I've been in your country many, many times. And there's quite a number of people who follow my work in acceptance and commitment therapy and in relational frame theory, contextual behavioral science. This is an opportunity for me to speak to students who are in linguistics, which is different from my usual audience, not just by country, but also by the field. And I'm not a linguist, and I'm looking forward to the questions. I'll do my best to answer them. I'm going to try, I'll look at the clock here, to try to keep my talk to an hour. It's very dangerous when you give a microphone to a full professor. They just talk, especially at my age. But I will try to be limited so you have time for questions. Perhaps you are seeing my title slide. If the organizers can tell me that's true, then I'll be reassured. But if I don't hear any screams, I'll assume that's so. And let's see if I can control it properly with my little arrows on the computer. Page down, let's see. No, I'm gonna have to do it with my mouse. All right, we'll skip this slide. I don't think we really need this. What do you want from a theory of language and cognition? Well, speaking just for myself, so you know what my orientation is, I think we don't need theories that are micro theories of this and micro theories of that so much as we need theories that are relatively comprehensive. It's fine to have micro theories, but the field can soon become an incoherent pile of little tiny theories. They need to fit together, however. The assumptions and the principles need to be coherent. I think, and here I'll probably part company from some of you, we need theories, models, that tell us things we can do experimentally, and when we do them, they have predictable outcomes. It shouldn't just be a field like history or something of that kind, speaking only about interpretation and coherence, at least speaking as a psychologist and a clinical psychologist who is interested in language and cognition because of how important it is to human functioning, I want something that is experimental. I want it to simplify, but not to minimize. Science at its best goes from the world of bread recipes in a long drawer that tell you what to do and what outcomes to get into principles that can simplify that long drawer into a very small number of things. In our best sciences, with things like E equals mc squared, we're able to come up with principles that simplify, but do not minimize. If you're saying, well, that's only this and that's only that, and you're riding over the details, the grit and grain of what we need to know, to me, that's unacceptable. It needs to be progressive. And what I mean by that is our theories need to grow over time in their ability to account for a larger and larger range of phenomena, but accounting for them, again, not just historically and interpretively, but also telling us what to do to change things. What is new? What is expected? What would be unusual? How can we apply these principles to change our world? And that allows you to be practically useful. For example, in language training or reading or helping children who don't have a sense of self or are unable to speak, or in the intellectual performance of school children, or being able to know how best to persuade an audience, and on it goes. If your theories don't tell you how to do those practical things, they're not progressive, or they're not simplifying, that they're not allowing you to actually change things, and they're incoherent and narrow, it's an inadequate theory. Now, where relational frame theory began 40 years ago was in rule-based insensitivity. When people have verbal rules about how to do things, speaking as a clinical psychologist, many things become now insensitive to its consequences. You begin to just follow what your mind, your rule-generating organ between your ears, does. But if we're going to focus on that, we need to be clear about what is a rule, what are verbal events, what are linguistic events, how do they work? And in behavioral language, we'd say, what's a verbal stimulus? And by stimulus, we just mean the antecedent conditions that have given behavioral functions. Now, Skinner tried to come up with an answer long ago, and Chomsky wrote a famous review, probably much better known to you than the theory itself. And I tried as a very young professor and as a student to apply Skinner's ideas, since I'm out of that tradition. And he broke language up into a number of functional units. You wouldn't necessarily know this unless you've done some reading in Skinner, but mans and tacts and interverbals and so on. And this is just a little diagram as to how they function. But I was not happy with them. For one thing, whenever I tried to apply these things, I couldn't come up with a sensible definition of what even a verbal stimulus was. If I back up, when you have a rule that's a verbal stimulus, in Skinner's approach, it leads to a whole bunch of different categories. But what is a verbal stimulus? And Skinner defined it as just a product of verbal behavior. But that means if I tell my dog to go get my slippers, it's engaging in rule-governed behavior. And that's nonsense. What you and I are doing is fundamentally different than what the birds are doing outside the window. We're now doing things, we understand things, we're speaking about things that would have been hard to understand even 10 years ago. Look at what we're doing right now. Across thousands of miles in real time, we're having a conversation. And language and cognition is what afforded that, what allowed that, what permitted that. The birds outside the window are not doing that. Yes, they have culture in a very limited sense of it, but they do not have the kind of progressivity. So all the other terms in behavioral thinking were defined functionally, but then there's this term in Skinner's thinking that wasn't. And to me, that means there's a flaw in his approach. And early on in my career, I abandoned it. My mentor at the time suggested that I instead look at what's called stimulus equivalence, which was a new phenomenon in behavioral psychology when I looked. Around 1981 was when I became aware of it, more than 40 years ago. And the first demonstration of it is in 1972 by a man named Murray Sidman, dead now, but a real hero of behavioral psychology, who showed with the solid arrows being training, the dashed arrows being derived relations, if you train a sequence of conditional discriminations, that means usually done in matching to sample, where you have an event, you have to pick another event from an array of events. So given A, you learn to pick B, let's say, and given B, you learn to pick C. He showed that you would show the inverse relations, and you would also show the combinatorial relations in a phenomenon called stimulus equivalence. This had been talked about in psychology in different ways, but the precision of the formulation that Sidman gave us really excited behavioral psychology, who was frustrated over our inability to understand language and cognition, because it gave us several things. One is that we could see how generative symbolic meaning or these kinds of relations are. And it was very difficult to explain using traditional behavioral concepts. But the most exciting thing is that it appeared to be relevant to human language and cognition. How did we know that? Well, early on, Sidman showed if you took persons with developmental disabilities, you could use this preparation to teach them language functions. Furthermore, if they were severely language disabled, they couldn't show these phenomena. And some of the earliest research on that came out of my own lab, showing that mental age could describe what the populations that were able to engage in this behavior, not, I think, because it's due to language, but I think because it's a core feature of human language and symbolic meaning. And I'm going to show you some data that I think proves that. So its relevance to human language and cognition is what really excited me, not just that it's an interesting behavioral phenomenon. But I challenged myself, when my colleague, the late Aaron Brownstein, a very wonderful basic behavior analyst, showed me this, to try to figure out why. And I spent an interesting, very small number of days trying to come up with an answer. And I came up with the simplest possible behavioral answer you can have, which is that maybe relating itself is a learned operant behavior. Now, often when we think of instrumental or operant behavior, we think of formal behaviors, like pushing a bar can be thought of not as an interaction with the environment, but the extension of the muscles in the forepaw to cause the deflection of the bar in an animal operant chamber. But I had been trained thinking of operant psychology in a more radically functional way. For example, in generalized imitation, we know that very young children have a few behaviors that are inborn: tongue thrusting, smiling, and opening your mouth. With an infant, if you go with your big mouth or with your tongue, or you smile, a neurotypical infant will imitate those things. But if you touch your nose, the infant won't do it. Soon enough, the infant will. And there's a lot of data showing that it's learned by exemplars and reinforcement, leading to this more generalized do what other people do behavior. So the behavior is not touching your nose, it's imitating. The behavior is not wiggling your ears, it's imitating. And with enough examples, it generalizes. We know that if you sit a person in front of a computer and have them push the numbers key in a way that is random, they can learn to behave randomly that beats any algorithm known of randomness. With non-human animals, if you give, let's say, fish to a dolphin for doing something it's never done before, it eventually can learn to show you trick after trick after trick after trick that are brand new. in order to earn the fish. So there's nothing in operant thinking that demands that the form of the behavior is what's learned. You can think of it more as a radically functional relationship of, for example, doing what other people do, or doing something randomly, or doing something new. Well, in the same way, why couldn't it be that we could learn to relate in a particular way? Now, at the time, this was a very hard go. For one thing, Chomsky version 1.0 was ascendant at the time, and everybody knew that Chomsky had beaten Skinner into a bloody pulp, or so the story had been told. And it is true, I myself became very frustrated and then abandoned Skinner's ideas. But his larger message was maybe these generative phenomena we call symbolic learning, symbolic behavior, verbal behavior, is learned by multiple exemplars. Well, today, even Chomsky himself has moved in that direction. We have large language learning models, which I don't think imitate how humans learn it, but it shows that multiple exemplars can indeed give you amazing levels of emergent phenomena that look very much like the language functions that we're used to. But at the time, we're talking more than 40 years ago, nobody believed, except a few little tiny voices in the wilderness, the ones left of the behavioral tradition, that experience alone could give rise to meaning and understanding. Now, 40 years later, that insight, I think, is more viable, and that a modern behavioral approach, but a different one, a new one, to language and cognition can be built around the simple idea that derived relationships among events, stimulus relations, I'll call them, define the core of human language and cognition, and relating itself can be learned. Operant or instrumental behavior can be learned by multiple exemplars. And how might that happen? Well, just take equivalence. If you have example after example, let's say in this new language I'm making up, a lemur is this round yellow thing. But let's say I'm also in a household that is has multiple languages, and in another language that the child is learning, a lemur is also, called a betrang. If you just had those two training things, a lemur is this round yellow thing, and a lemur is also called a betrang, you would know as a child, and you would know just as a listener listening to me right now, that a round yellow thing can be called a lemur, a betrang can be called a lemur. These are mutual entailment. Relationships that learned in one direction can be derived in two. But also that a betrang is that round yellow thing, and that round yellow thing is called a betrang, even though you never even saw them together. But you could combine these relations in the phenomena of mutual entailment. And furthermore, if one of these events had a function, such as that round yellow thing may have many functions for you. There in Brazil, I've had many glasses of iced tea with the lemons that grow there. And I know that this round yellow thing is sour. It smells in a particular way. It's a citrus. You can use it to make lemonade. The skin is bumpy and so on. It has functions by exposure. But I could do the same thing now, even to the people who are listening to me with betrangs. If I asked you to imagine cutting into a big, juicy, fresh betrang, bringing it up to your mouth, squeezing it hard without any sugar in it, and taking a big gulp of betrang juice, I know that if I'd had cotton in the mouths of all of my listeners before I said those last few sentences, and after I said those last few sentences, the cotton, if we spit them out of your mouth, is now heavier because some people are salivating at the idea of sucking on a betrang. Why? Because there's a transformation of stimulus functions. That's how fast it happens. You never heard anybody say that a bitrang was a limu, and because I showed you the picture, you know how to translate that into your own language, but also to take the functions you know about these round bits of fruit, and it's now available to you with regard to an arbitrary stimulus event that is related, in this case, in what I call a frame of coordination, a naming kind of relation, an is relationship, the kind of relationships that are studied in equivalence, that gives bitrang now some of these functions. Transformation of functions means the functions of the relata in a relational network are available under contextual control as transformed by the derived relation between the events. Now, if that's true, I can extend that out in a relational context, such as the context for equivalence. We have words like is. This is that is a contextual cue that says this is a particular kind of relation. And over again, I say, a lemon is this thing, or a cheeseburger is this thing. With enough training, could I look at an object such as this one and say it's a tree, and have the child be able to now derive, because it's been trained in both directions through multiple exemplars, based on that cue of is that would apply a particular kind of relation, could I derive that a tree, said as a word, is that class of objects. So on and on it can go. And as you have particular functions, I could be able to say things like, what does a burger taste like? But I could also say, what does a burger smell like? Or what does the burger bun feel like? And those words taste, smell, feel would be contextual cues for particular perceptual functions of this event that now may be available to this oral name, perhaps in this imagined training through its relation to a written name, burger. But if that's true, if relating itself is learned, then it shouldn't stop just at equivalence, because I should be able to say, let's say, that this one is smaller than that one is smaller than that one, and have you derive, if I later say that this is the small tree, the medium-sized tree, or the big tree, to be able to derive the same kind of relations that I've been taught with other events, even if the events are not organized sensorily by relative size. What am I talking about? Well, I think even in Brazilian coinage, and it's certainly true in American coinage or with euros, there are some coins that are bigger physically, but are worth less in terms of nominal value. In American coinage, a nickel is bigger than a dime physically, but smaller than a dime in terms of value. A quarter is bigger than a dime in both senses of the term. But our training could disambiguate the physical relations of size into derived relations, such that a very young child may prefer a nickel over a dime because I know coins can be used to buy candy. But as I get the verbal concept of relative size, I may prefer a dime over a nickel, even though it's smaller. That's an example of how a functional cue can be used to select particular functions of a relational network. In this case, the function of being able to purchase something. Now, when we've trained this, what we've done is we've taken with very young children, for example, a context. Let's say in the context of a white border, I train a child to, given a short line, to pick the short of several lines. but in the presence of a red box, given a short line, to pick the longest one you can find among the alternatives. You could say metaphorically, this would be like a cue that says pick the same thing, or this one, pick the different thing that's as far as most different as you can make it. You might call it an opposite. If you did that, and then you did, let's say, arbitrary matching to sample, where let's say in the presence of A1, I pick C1 instead of C2 or C3. I'm using the language of letters and numbers to mean any squiggle, any picture, any word, any event. Could be anything. Trigrams, whatever. Given A1, I could train, let's say, in the presence of the white box to pick C1 from an array of several things, or B1 from an array of several things. But in the presence of a red box, which we'll just use the word opposite so we can remember what this pre-training might do to the child, to pick, let's say, given A1, to pick C2 and not C1 or some other event, or given that same A1 to pick B2 and not B1 or some other event. That could be trained, and it would, of course, be easy to do. I think you could see how we could do that. But then if you think about the derived relations that would come by the pre-training about the relational cues that would indicate what relational learning are you applying to this very similar situation, you would get a network that would look something like this. We've trained as opposites, we've trained as same. But when we test them now, we would find that, yeah, in the presence of red, they're both show mutual entailment. But the combinatorial entailment is now quite different, because in both cases, C2 and B2 are the same, C1 and B1 is the same. So over here, the same cue that was used to train the network would lead you to derive these unlinked parts of the relational network. But not over here. If you use that red cue, given C2, you wouldn't pick B2 because an opposite of an opposite is not opposite. An opposite of an opposite is the same. So you would only do it in the presence of the same cue. And the same is true of the combinatorially entailed relations. You would pick, let's say, given C2, you would pick C1 only in the presence of a red border, not a white border, even though your only history of reinforcement for picking C1 was when you had a white border that indicated same. What I'm saying is that the combinatorial and generative qualities of relational networks, of symbolic meaning, can readily be modeled from this very simple idea that relating is learned, but it has two simple features of mutual and combinatorial entailment as you build out into even more complex phenomena, but the core of it. But these are under contextual control of the relation applied and the functions that are relevant. So relational frame theory at its core needs only 5 terms: mutual and combinatorial entailment, transformation of functions, and cues that control the relation or control a particular function. We will call the specific types of these phenomena relational frames. And a general term for them is arbitrarily applicable derived relational responding, or when people use it within initials, they drop the D and they just say AARR. What do I mean by arbitrarily applicable? I mean that, yes, of course, when you're looking at physical things, you can have relative size. But when you're dealing verbally with those things, relative size is now no longer a guide. It's attributed size based on the relational cues that tell you, for example, that the bigger coin is actually smaller than the bigger coin is actually smaller than the smaller coin physically, such as in learning the relative value of coins. So that means while it's not arbitrarily applied always, we can look at the moon and say how far away it is. We can look at 2 objects and say which one is bigger. And so can on some of these performances, not the moon, but two objects. So could a chimpanzee or a pigeon or maybe even a cockroach. But it becomes abstracted from this physical world and is now can be applied arbitrarily. And what I mean by that is under social whim or convention, but it is still a form of relational responding that is learned. So that's what a relational frame is. It's a specific class of relational framing, of relational responding that has these contextually controlled qualities I talked about, is due to a history of relational responding relevant to those cues, a history of reinforcement. And it's not based solely on the non-relational training with regard to those stimuli or their non-arbitrary characteristics. Why would you want to call something relational frames? Well, it's the simplest unit that can do what we want symbolic learning to do, namely describing different kinds of relational responses and that fit together to create speaking with meaning and listening with understanding. Now, that's a longer argument. I can get into it a little bit with data, but also with our discussion. But it is not a primitive. I'm not saying your brain is pre-wired to do this. We are evolutionarily prepared, I believe, because we're cooperative primates. And the initial act of a frame of coordination, I think, is an extension of human cooperation. If I say, if I had a name for apple, let's say, and a characteristic oral event in the presence of stimuli is very common in the animal kingdom. Look at an eagle. If you're a prairie dog, squeak, run into your hidey hole. But if I can then derive that when I use that name, I also want to be provided with the object, such as calling to my mate across a canyon for a masa because I want an apple, I will sometimes be provided with that. And so the idea is that this evolved because of the social primates that we are, but then as culture began to evolve, it was able to go beyond simple naming relations into these more complex relations I'm talking about, as a verbal community was able to support new kinds of relational framing, such as before and after, or I and you, or here and there, or bigger or smaller. And when that begins to happen over a period of hundreds of thousands of years, very likely, we finally have the breakout that happens in recorded human history with written language and the impact of relational learning on our other phenomena. So here's the central claims of RFT, that there are relational operants, they form a core process in human language and cognition, and they impact on other behavioral processes that are previously known, such as operant and classical conditioning, imitation, social learning, and so on. Well, are there relational operants? Well, now 40 years later, we can say firmly the answer is yes. It walks like a duck, it quacks like a duck, it behaves like a duck, so it's a duck. It shows development, as all operants should happen. These are just showing derived symmetry across the months in a normative developmental period. You can bring relational learning under contextual control. This slide won't allow you to unpack that, but I give some references in the article, available in Portuguese, by the way, on the flyover of 35 years of RFT research. We know that consequential control matters. If you don't give proper feedback that these things go together, it's not derived. I won't walk you through that, but I will walk you through some other things. We know that they can be shaped and modeled into different forms. At least 40 studies or so have shown this, and several have showed that the units can be broken apart or assembled. So it's not a primitive. You can arrange conditions where symmetry or mutual entailment doesn't lead to combinatorial entailment and so forth. I'm not arguing that it's a primitive or in your brain or your language acquisition device or any such thing, but it is a coherent unit that is readily formed and is the smallest unit that does the most things. So while you can break down relational framing into smaller units and you can extend it out into bigger units, I find the metaphor, and it is a metaphor of frame, to be useful. Now, how do I know that they can be shaped and modified? Well, give you the coin example. This is just an example through kind of a multiple baseline of working with a very young child who can't do relative comparison just by attribution. And we train, A is bigger than B, A is less than B, mixing them together, putting them in a larger network, mixing it all together, and so on in multiple steps. You can go to the article, Behrens and Hayes 2000. It's in a Journal of Applied Behavior Analysis. And all you should see from this is when we train it, it gradually gets better. Each time there's an increase in complexity. We can train it with a child who starts out unable to do these things at accuracy. But when we do, these are the same children. These are now their generalization to new coinage, where we make up coin systems and we just say, this one's worth less than this one's worth more than that one, in an order that fits these kinds of steps that are in the middle part of the second slide. And you see these improvements as the children are trained, and almost all of them get to near 100%, or very, very high. In other words, you train it as if it's a general behavior, and then they show that. Now, I'm seeing nothing but gibberish in that slide. I presume that's all you're seeing. But this was a demonstration that you can get semantic priming using relational networks, not just with words that the person already knows. I'm sorry you're unable to see this. This is a study showing that when you do relational training, such as in stimulus equivalence, and you look at the neurobiological response to these events, do they appear to the person to belong together? You show one stimulus followed by another one. You can show that the directly trained events, this is on high density EEG response to boom, boom, showing two back to back, sort of like I might if I said doctor, nurse, or lawn mower, or lake, stream. If I do that, the trained relations and the equivalent stimuli, the way I've already described earlier, show up neurobiologically as if they're the same thing. But if I said something like doctor, motor car, it would show up with this this negative, they're called an N400 response, as you show a neurobiological response 400 milliseconds in, that no, these don't go together. My point of this slide, though, is the brain can't tell what you've put together by semantic learning and what has been put together by experience, which is a little odd and a little distressing. If you look at more sophisticated forms of neurobiological research, such as fMRI, you see the same thing, that the neural activation patterns of derived stimulus relations are the same things you see in semantic processing. I can give you the references. I'm going to talk about intelligence here in a second. We know that if we train relational framing of different sorts, like in this case, I was training with a young child who couldn't do it. IU, here, there, now, then. This is published now, Wheel and Hayes. As the training occurs, you see this increase, but you also see theory of mind probes of being able to enter into stories, social stories, and understand them from the perspective of players in the story also increases. In other words, we can take the cognitive phenomena that underlies things like perspective taking, focus on the elements such as learning I, you, here, there, now, then, and we begin to see some benefits in perspective taking. It's not all that there is in perspective taking, but it's a piece of it. Some of these references I don't have on the slides, but they're in the article and I can provide them to you. I was putting these slides together this morning at very fast pace, grabbing some things. This is a little study. There's the title, 2018. I think Mark Gexon is the senior author, showing that relational learning abilities of the sort that I've been talking about correlates very nicely up around 0.8 with IQ. And it's not, I think, because IQ is why these relations happen. I think it's because these relations are part of what we need by intellectual performance. Now, how do I know that? Well, here's a small study done back just a few years ago where traditional Skinnerian approaches and special ed approaches were used with persons who had an intellectual disability or not. And this is a relatively short training. I think it's 6 weeks, just half an hour a day, something like that. Or we included in the training in relational operants. And this is the resulting change in the full-scale IQ scores of those children. And you can see almost a 12-point jump up over a 6-week period. This has been replicated in a larger study. This is a new one that came out just about a year ago with children who are on the spectrum, autistic spectrum disordered children, randomly assigned either to receive special ed services for 6 to 9 weeks with 6 hours of therapy per week, so just about 1 hour a day, or they receive a relational training curriculum that systematically drives up their relational learning abilities. I'll give you an example. It's the kind of things I used to do with my children when driving around. I would drive up, this is not exactly what's in the training, but to give you an idea of how you might train these things. And I would say to my 3-year-old or 4-year-old in the back seat, I'm coming up on a red light. If red was green and green was red, what should I do? And even very early on, they could learn to say, you should go, Daddy, you should go. Well, then I would say, there's a red light I'm coming up on ahead of me. If red was green and green was red, and forward was backward and backward was forward, what should I do now? And I remember my daughter, Esther, who's a very gifted and talented kid, and this was an indication of it. I think she was only 5. She said, do nothing because the red light is behind you. So you can train the network implications. And when you do, what begins to happen? Well, this is just a short randomized trial done in the state of Hawaii, where relational training, you can see the full-scale IQ scores before and after the 6 weeks versus special ed, including using Skinnerian operants, which had no effect, versus an increased effect and a significant difference between the two. The state of Hawaii has now dedicated a $40 million grant with their entire special ed population in that state to receive relational frame training based on, this is, I think, the second of 3 studies showing this phenomena. So what do we want? Testing the claims. Are there relational operants? I think we can say yes. Are they a core process? I think we can say yes to that too. They seem to do the kinds of things we'd expect that a theory of language and cognition can do. But I'm not a linguist. I'm not just interested in language. I'm interested in language because of what it does with my patients as a clinical psychologist, because of what we can do in schools as educational psychologists or as teachers or trainers, because of what we can do in the world in terms of helping people deal with things like fake news or with rising to the challenge of climate change based on the implications of scientific data. Do they operate on other behavioral processes? The answer is yes, and here's an example. This is a study done with a very simple relational learning network, learning that I'm saying A and B and C, but these were actually squiggles on a screen, just little graphic images. And half of a group was trained that A is less than B is less than C, much in the same way I showed you earlier, pre-training the cues, then training the relational network, or they received no training whatsoever. And then this middle stimulus was paired with shock over and over and over again. So it had a function. When people saw the B stimulus, they started to sweat, expecting shock would happen. So here's the preparation. You have a group that has that relational network. You have a group that has no training, and everybody gets shocked with B. The question is, what happens when A or C is presented? Oh, shoot. It doesn't show it. Oh, that's so mean. Okay. What I'm seeing is another screwed up image. I'll have to tell you what happened. What happened when you saw the B stimulus, of course, you sweated in both groups a lot because you'd been shocked when you saw it. When you saw the A stimulus, you didn't sweat very much if you hadn't been trained in the network because it looked completely different. Or if you had been trained in the network because A is much smaller than B. And so therefore, if this leads to shock, this will lead to much less. In this stimulus, though, if you hadn't been trained, you didn't sweat very much. But if you had been trained, your response of anxiety, even though you'd never been shocked with C, was orders of magnitude higher than your response to the one where you had been shocked. Now, I'm a panic disorder person in recovery. This is part of why I developed ACT, part of why I got interested in how language and cognition works in my history. And I can tell you how this works. When I was really struggling with panic, if I had to give a talk to 500 people, it was scary, but it was at least sane, and I could sort of make myself do it. If I had to give a talk to 3 people, and I was getting overwhelmed by anxiety, that was much, much worse because it showed that I was nuts. I was crazy, and my life would never work well, which my work in acceptance and commitment therapy solved that. But my point being here that cognitive relations can give stimulus functions that are no longer bound by your actual experience. Logically, just a few people should be less scary than 500, but that's not how the mind works. And so logically, a stimulus you've never been shocked to should be less anxiety evoking than one that you've been shocked many times to. But when you framed it that this is much bigger, regardless of size, just like I framed the situation of talking to 3 people is much bigger than talking to 500, because it shows how crazy I am if I get anxious, then you can get these kind of extraordinary effects. So they operate on other behavioral processes. Are they useful to application? Can we do something about it? Well, I've already shown you multiple examples. I told you about what the state of Hawaii is doing. I haven't really done a deep dive into my clinical work, acceptance and commitment training or acceptance and commitment therapy, but it's based on ACT, and there's more than 1,000 randomized trials. It's distributed, as the introduction said, by the World Health Organization. The single most frequently downloaded document on the World Health Organization website is an ACT self-help book. And all of this came out of relational frame theory. I don't have time to walk through it here, but I can tell you there's books available that help you do that. So unlike many of the things you might learn in linguistics where you say, okay, who is this going to help and how is this going to change the world? And there may be long pauses. In the case of RFT, there's a quick response because we have many examples. Let me just give you one and then we'll stop and take questions. And I will have met my goal of speaking less than an hour. We were interested in can you use RFT to identify what really motivates people? And if we presented what really motivates them, would they then work harder? Would it function as a good motivator should? So we took 46 female students in a spinning class. That's a name for a class where you ride stationary bicycles as fast as you can under the control of a class instructor who tells you to go faster or to slow down, and so on. Students were randomly given either a form-based prompt where the teacher would say, please take what's in the bag on the front of your bicycle out and do what it says. And one of the things would say, the best way to ride a bicycle is with your back straight, your head up, and focus on moving the pedals, not just with the downstroke, but also the upstroke in your toe clips that will make that possible. Or in the bag was a little positive statement that had been filtered by an implicit measure of cognition drawn from relational frame theory. I can't easily explain this implicit measure. I'll give an attempt to do it, but if you don't understand it, you're going to have to look at the literature. And basically what you do is you give people cues that allow them to say how events should be responded to. It would be like this. Suppose I said with American coins, show me the small one. And I had the smaller one. And I had, let's say, a dime, a nickel. No, let me do this. Show me the smaller one, and the smallest one, and I had a quarter, and I had a dime and a nickel as comparisons. You should pick the nickel. But if I said something like, show me, I said something like, do the opposite of what I say. Show me the smallest one. Then you should pick the dime and not that nickel. Now, this is just one form of what's called the implicit relational assessment procedure. It's a form that I developed called the multiple trial IRAP. It doesn't matter that you fully understand. Let me just say it this way. We can set it up so that based on your relational network, you would do one thing. Based on the contextual cue you're providing, you have to fight that and do the opposite. That takes some time if you know what's being said. If you didn't even know what smaller and bigger coins meant, you would just pick the smaller physically, and that you could do very rapidly. So we essentially set up a competition, and because of that, we can guess what the meaning is, even though you weren't saying it out loud or being trained out loud. So it's a kind of an interference test to get at the implicit relational networks. Anyway, using that method, we had identified for each of the persons in this class what really motivated them. And to give you an example, some people were in the class because they wanted to be healthier. Some people because they wanted to lose weight. Some people because they wanted to look beautiful. Some people because they had a trip coming up and they wanted to ride with her boyfriend on a long trip. On and on it went. And when we presented those, so some of the subjects get a thing that says keep your back straight, focus on pushing down and pulling up with your legs. And in another condition, it would be focus on the long ride you have coming up with your boyfriend. And when we did that, these positive goals that have been vetted by relational frame methods, these are just individual people, led to significantly higher effort in terms of spinning. And we did it by the percentage of the instructor's heart rate. So the instructor, when she said, go, 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 she would go, go, go. And so you could just look at it as the whether or not you're matching your instructor and keeping up with them. We also, just to make sure, did a study where we took the IRAP and we took the implicit measure and we took the ones that shouldn't have worked and we compared that. So in the ones that where it should have worked for almost every single person, they pumped a lot harder when they were presented with their implicit goals versus when they were presented formal guidance. One subject not, but almost everybody else. But then when you, in another study, gave them implicitly tested ones that shouldn't have been especially good, you can see the green lines were down, not up, showing that you could use relational learning to determine what really motivates you, kind of in your, I don't want to say unconscious mind, but even if you're not really thinking about it implicitly, and you could also predict what would not be motivating. So I'm to my final slide, and I am, by my clock, 7 minutes early. Here's what we want from a theory of language and cognition. Speaking as a psychologist, not as a linguist, maybe you want something different. But this is what I've spent 40 years of my life in one aspect of my research program trying to produce. And I do believe it's the best available, most studied, most broadly useful approach to language and cognition known presently, is that we want a theory that's comprehensive. I've skipped many things, how we can understand metaphor and our research on that, how we can understand a little bit of persuasion. I've given you that with that last one, but there's some domains I've skipped, but I think it's rising to the challenge. There's nothing that I know of where you would say, boy, here's something that a theory of language cognition has to do, where there's no data in support of that in the case of RFT, or there's actually contradictory data. I'm unaware of those. Maybe in the questions you can give me some challenges, and that might help us in some things that need to be done. Coherence, the idea of thinking of this as learned instrumental behavior is now not so radical with large language learning models and with what's happening in linguistics and so forth. Enough of multiple exemplars can do amazing things, even emergent phenomena. If you look at the emergent phenomena in ChatGPT, it's doing things that nobody ever programmed, nor did they ever expect. And some of those challenges of Chomsky to Skinner that basically sneered at the idea that you could ever explain the generative nature of language using multiple exemplars and learned phenomena, I think now is just no longer very telling. I admit that Skinner's approach was wrong, too limited, but it was the beginning of something that I think we've built on. It's experimental. I've shown you several experiments, and it can continue to be so. It simplifies but does not minimize. That's my opinion, and my opinion being that I'm able to take any of the cognitive tests that you'd want. I've shown you a few. Well, my computer hasn't cooperated with showing you the data, but semantic priming, our response of our underlying neurobiology, being able to help children with their increasing their intellectual performance, and so on. I think there's pretty good reason to think that we're not just waving and minimizing and saying, oh, well, that's not important. No, I'll take anything you think's important. Progressive, well, it's progressed massively over the 40 years. We've walked through this research program one step at a time, and it's now at a point where finally the behaviorists, who, by the way, rejected this for many years, only within the last 10 years have they begun to take it seriously. now are getting very large grants because they've shown they can actually do things that nobody expected you could do. That's pretty progressive and practically useful. And there's the challenge that I really feel most strongly about. And here's where I will end and take questions 4 minutes before my 1 hour goal, which is, while I understand that not every field is an applied field, I come out of a wing of psychology that basically says what is true is there's a special sense in which scientific knowledge is true if it can lead to the most effective action possible. That's a direct quote from Skinner, word for word. I've always believed that's true. I don't want knowledge that you can't use. I'm okay if people want to study that, but as a practical person who understands that the people paying for the University of Campinas or the University of Nevada, Reno, are sometimes cab drivers, are people who do not have a lot of money, I think we owe something to the world if we're in the academy. And we should seek out as best we can to always remember that we should be held accountable to make our knowledge ethical, moral, sensitive to the needs of the world, and where it's possible, practically useful to the citizens who, after all, pay for our salaries. So that's my talk. I'll take questions, and I hope you found it interesting. I'm looking forward to what you think.
Professor, thank you so much. It was so interesting. We have some questions, and let me ask you the first. So we have this one from Josie that is right here. So is there any relational frame that is uniquely human?
They're all uniquely human. There's not a single example of relational framing in non-human animals, not one, that has been able to be replicated and built upon. Now, we have seen in some of the basic labs people redefining and saying, well, relational responding is sort of like this. And sort of by the time they finish, I know the results of the experiment because I can recognize, oh, that's a well-known phenomena in non-human animals. I'll give you an example. If you had a class of events that were positive and a class that were negative, and you trained the animal only to respond to this class and not that class, and when they did it very, very well, but there's many elements in it and they're arbitrary, now I switched them. And now in order to get food, you can only respond to the class that you used to never get food if you responded to, the so-called S minus, stimulus minus, and not the so-called S plus. But they're arbitrary collections. You flip them, the animal contacts it. Oh man, they keep doing the wrong thing. Finally, now they start doing the right thing. Now you flip it again. Then you flip it again. Then you flip it again. 4 or 5 times in, 1 or 2 trials, the animal will easily show you, well, I'm sorry, dude, that is a functional class based on direct experience. That is not symbolic learning. And so what has happened in the animal learning tradition is sometimes they're trying to grasp and hold on to their relevance because nobody wants to pay for animal labs anymore. In Brazil, there's a few. You can go to Pará and find sloths in the basement. And I'm not sneering. I did much animal research myself, but enough already. What we're doing right now is not what non-human animals are doing. And I just think it's incredible to think that it is. Doesn't mean there's no relation. Yeah, we're part of the animal kingdom, but we're doing something extraordinary here with language and cognition. And I don't think it helps to say, oh, well, that's just this and just that, if you have to distort the phenomenon. And, the collie that has 1,000 words They're not words. The collie does, Irene Peppergurd's parrot will say green if you hold up an object. Excuse me, that's generalization. It's stimulus generalization. That's very easy to show. It's, Skinner had pigeons playing ping pong. So what? Unless they're going to write me a paragraph of what it's like to be a bird, I'm not listening. I just am very frustrated with this line of work. When you get precise, and I've done it with relational framing, I've given you 5 features, very precise, not one demonstration. Well, I take it back. There was one sea lion by a guy named Schusterman. The sea lion was named Rio, that was trained through multiple exemplar training on relational phenomena that might have shown equivalence. 1 of 3. It took 10,000 trials. It was never replicated. He made some errors in the method, and it took so long the sea lion died. So maybe it's possible with enormous effort, but it's not the collie with 1,000 words. And please don't email me about your cat. I know your cat is very smart, but I'm sorry. What you and I are doing right now is human. And I'm not doing it by declaration. I'm not saying it has to be human. I'm just saying every time we've looked, we can't get, well, I'll give you an example. In Atlanta, there's no longer, but there's a troop of chimpanzees that have learned plastic symbols. You may be aware of this troop. When Neil Dugdale and Fergus Lowe went there and took the pride of the troop, the best chimpanzee in that Yerkes troop, when they tested for symmetry, you test it in one direction and then you see, did the animal derive it the other direction? The responding was at chance level. So, and I'm coming from a department of psychology where Washoe the chimp, which you've probably heard about, the late Alan and Trixie Gardner, I've visited Washoe. I ran and hid in my office when Washoe came because Washoe would bite you. He was a wild animal walking through the halls of our department. I'm sorry. No, Washoe never showed anything like stimulus equivalence or relational framing. It did show interesting things, the water fruit or something with forms of generalization with things like a watermelon. So I'm sorry for the long answer. I should have been more precise, but in my opinion, the answer is no. There's no examples outside of human beings.
Okay, no, that's great. Thank you so much.
Next up, this one's my professor. It's here. Does your approach work with the idea that there are innate instructions in human cognition? I don't know if I didn't understand it, but it wasn't clear for me.
Probably not. The sort of innate structures in the sense of the deep structure grammatically and so forth. Some of that may be forced upon us by how we disambiguate relational responding. This is a very difficult conversation to walk through, but when, for example, if you read from left to right versus right to left, you have a different way of interacting. Suppose I showed a stimulus and then I showed a larger stimulus and I wanted to train a relational cue. If I had no idea that the first one, now followed by the second one, involves kind of a direction, from the first one to the second one. And suppose your concept of time was upside down and things that happened later didn't have to have any sense of primacy. Well, if I have to train something like before and after, through multiple exemplars and I have no words, I challenge you to do that. Grammar allows you to disambiguate that. But without grammar, it's very hard. When I've tried to model it, because I've tried to build preparations that could be applied to non-human animals. Why did I do that? Because I come out of the tradition that says maybe there's nothing special about human beings. So we always wanted it to be something a chimpanzee could do. You know, maybe not a pigeon, maybe not a cockroach, but even a pigeon, it'd be good. Cockroach, a little harder. They do relational learning, by the way. They will learn relative darkness of a hidey hole, non-arbitrary, you know, physical. Even cockroaches have relational learning capabilities, but not relational framing abilities. Well, so this is a long-winded way of saying, I believe the universal structures may be tapping into the necessary structure of the multiple exemplars needed to disambiguate the directionality of relational learning. And so the answer would be, no, it's not an 8, but all human language systems are going to show it. Because it's a requirement. It would be like saying there's no innate difference between up and down, but if you're an athlete, you need to know how to jump up. If you only jump down, you'll never be an athlete. I can fall to the floor, I will not have any muscles. If I try to leap a meter high, I can develop muscles. That's a structure of the environment and my interaction with the environment. It's not arbitrary. And in the same way, some of the deep structures, so-called, or the non-arbitrary features of linguistics may be built into the environment, organism, behavior, interactions, and the conditions under which you can get relational learning to occur such that you get this generative, arbitrarily applicable. Because if something happens when you break free of form, I can mention one more thing. Consciousness is part of this. And I've recently written an article on the qualia of consciousness and argued that you needed a biphasic relation, that consciousness is the story of evolution if what you mean is greater and greater ability to respond to consistencies within and between yourself as an organism and the environment, so both internally and externally. But when you're able to get perspective taking going, such as children when they hit around age 3 or 4, and they can kind of metaphorically step out and look back at themselves, then there's a break and there's something qualitatively different that happens in consciousness. It's now no longer just better sensation, better perception, etc. Even the early parts of relational framing look to me like just a very small step forward in consciousness. But once you can step out of yourself, look back at yourself and reflect on yourself, that's very different. And there's another example where a universal human phenomenon of this kind of higher level consciousness that we're talking about with the qualia of your contact with your own experiences, which is in all human cultures, may be kind of a constant and in all human groups, not because it's inborn, but because it's a feature of complexity of environment, behavior, interactions that emerges. There's an emergent phenomena that happens that is built on these building blocks of frames of coordination, naming, difference and opposite, perspective taking, but then perspective taking looping back and a break happens, and now we're off into a very, very different world. So I hope that gets close to an answer. I'm sorry, it's a little complex.
No, it's great, Professor. Thank you so much. I actually I'm finishing my PhD in language and theory of mind. I study theory of mind since 2016.
Sure.
It's been a while, so I was very interested when I saw the slide that you mentioned, Tom, and then I will look for the article you
Yeah,
mentioned.
there's more to theory of mind than perspective taking, and it requires. We do know that some of the features of theory of mind can be understood from relational learning, but
Nice,
it's
nice to know.
still being researched, and I think there's a lot more that we're going to need to do. So I don't think we have a turnkey answer, but we do know that some, and I showed you a little bit of data, some of the things we're studying on perspective taking, for example, what we call dectic frames. They're frames that you can learn only by demonstration because they're not defined by the related events, but by your perspective on them, like left, right, up, down, I, you, here, there, now, then. The skill of learning that is part of theory of mind, but there's probably more going on there.
Nice. Good to know, Professor. It's very interesting. So the next question is from Maria Eugenia that was here with us, but she had to leave. So her question is, you mentioned some applications of these studies for therapies and education. For instance, would you give us some more concrete examples of how this is could be applied?
Well, I would flip it around and say, give me an example of something that you'd want a theory of language and cognition to be applied to. And I'll tell you if there's any research there. But examples of how it might be applied, well, during President Obama's time, he developed a new form of health insurance. And in the US, we have a very chaotic health system, nothing like yours in Brazil. When I got sick in Brazil, I go to a hospital and you take care of me. In the US, it's all about money.
SUS.
It's very terrible. And frankly, in the Brazilian system, I'm talking to doctors who've often been trained in US hospitals and so forth. They're very well trained. Anyway, you have a very good healthcare system compared to ours. But we had to get people to enroll. They had to sign up. So I was hired by the state of Nevada to do a test of the meaning of words used in advertisement and of images. And I wanted one that would be appealing to people who had never had health insurance, didn't even know how to apply to health insurance. People are very poor, never worked in a job where health insurance was part of their benefits, but also didn't offend or frighten, because at that time the right wing was trying to frighten everybody that there'd be death panels and old people would be put to death, just crazy, crazy stuff. I'm sorry for talking in terms of left and right, but it's true. The righties got very crazy about what Obama was doing. Well, I was able to do that using relational frame skills and go back and say things like this. Don't call it government insurance. Don't use the word federal. Only use the word Nevada. When you're talking about insurance, use the word health. When you're talking about motivation, talk about family. When you're showing pictures, make sure that they have some diversity, but also make sure the doctor is wearing a white coat. All of that I didn't know beforehand, but I could use the tools of RFT to determine what would be the most persuasive images. In the article, the flyover article, I talk about the data that are coming on metaphor and understanding metaphor. Well, you can use RFT to create apt metaphors. You can deliver, such as a clinical metaphor, for example, deliver them in a way that has more impact. Let me give you an example. in my clinical work, acceptance and commitment therapy, there's a classic metaphor. There's many, many metaphors in ACT. But one of them is the phrase, anxiety is like quicksand. Quicksand is this kind of mud you get when if you get in it, it's very hard to get out. And if you struggle against it, you can sink in peat bogs and things like that. So you want to be careful. You can actually sometimes drown in a deep mud pool simply because you're struggling in the wrong way. The safest thing to do is to lie out on the surface of the mud. Increases your surface area, your weight is the same, and then you can roll to safety. Well, that phrase, anxiety is like quicksand, gives you some common sense way of thinking about what you might do when you're feeling very, very anxious and you're having a panic attack, something I know about very well from the inside out. It's where my work started from. I haven't had a panic attack in 20 years, but I can still remember what it was like, and it was not fun. Well, okay, so that's nice. That's just understanding what we already do. No, but it's more. From an RFT point of view, if you take metaphor and you have a ground, the relation between two relational networks connects, and then something is missing in one relational network that's present in the other relational network, right? Well, if you're going to get that transformation of relations and then stimulus functions, this connection has to be very, very strong. So we started doing this, and then we did some studies showing that this was true. So anxiety is like quicksand. It would be like if you got stuck in the mud and you're breathing really hard and you think, I'm going to die, and your heart is pounding and you're sweating and you feel like, I'm going to drown, and you're deliberately using words that are just like what panic disordered people would talk about to feel intensely anxious. Why? To build the strong ground, because the perceptual functions have to be similar. And then this counterintuitive idea that maybe I need to lay out flat. In the case of anxiety, maybe I need to open up and actually feel anxiety. Not by diving down into it, but being open to its different effects, like on my body, on my memories, on my imagery, would be more easy to put together. Say, here's something that's missing in how you're thinking about anxiety. I'll do one final one. Clinically, we used to talk about this witnessing, noticing sense of self that comes from dictic frames of I, you, here, there, now, then. And it's the core of what we might call mindfulness training. If anybody does meditation work, you know that there's a place in which you have a kind of an equanimity as an observer over what your body's doing, what your memories are doing, etc. And those were talked about in ACT as a frame of distinction. I'm not that. I'm not that. And there's some meditation traditions that meditate on exactly that. You'd look at the things around the room, and each thing you see, I'm not that, right? Yeah, but those experiences are part of me. So it's also true that I include that. Well, that's a different frame. So we've tested those frames. Turns out both are helpful, but inclusion or hierarchy is more important than distinction. So some early ACT work was very strongly focused on distinction. That's all gone away now. Because the basic research says, no, you can say, I'm not that, but then also remember to say, and all of that is in me and with me and will come with me. I include my memories. I include my past trauma history. I include my fast beating heart. But that doesn't mean that's who I am. That's the distinction part. It's more what's within me and contained. So I could give you literally hundreds of examples. I've given you 3. But if you read in the ACT literature, you'll see scores easily, quickly. But if you then get looking more broadly, I would answer your question this way. What would you want a relatively adequate theory of language and cognition to do? And if you're clear on that, give me a chance and I'll give you an indication of places in the beginning to do that. It's a massive agenda, so it requires many hands to be on deck. And one reason I said yes to this, that includes the linguists. I've been very disappointed that it's taken so long, 40 years, for linguistics to wake up to the fact that there's several hundred studies that are very actively doing good for the world. That doesn't mean it's right or true or correct. It just means it's probably worth at least a little bit of attention from the part of the world that studies language and how it works. And so I hope that I will see more in the field of linguistics. And I will mention one final thing. We are now able to train large language learning models using relational framing and get better models. It's coming. I can't give you the study yet, but I can give you a few of the measures that are out there that are feeding the AI. So maybe we can do a better job of some of these very new things, like using AI tools to understand language, using what we know about how to put language into the behavior of children that don't have it, and to use it to modify the behavior of language capable people when they get wrapped around cognitive processes that are entangling.
Amazing, Professor. So you have to come back to tell us more about this last study when it's finished.
That's pretty wonderful. I've been trying to learn your relational frame theory, and that's not something that, as you know, that we study as linguists. Behavior isn't something that is not really a part of what we do, mostly because linguists start from language as a product. We start from there from corpora, from outputs, from people talking, and then we start from that and try to construct something or say something that's more usual of what we do. We wouldn't really, yeah. And yeah, I think that's why we haven't really been studying behaviorism, but I know that you have lots of insights and information there. So I've been trying to catch up, and I'm really fascinated with your work. So thank you very much for being here.
Of course, I do have to say, in the history of linguistics, there have been those who want to do the deep dive into the how and why that leads to the products. And Chomsky himself was very interested in that. And he's just an example. So I think maybe, especially as young people and young academics and students, you can make your own choices as to how big your field should be and how deep it should go. But there certainly shouldn't be anything we know about the how and why that contradicts what we know by understanding the product and going forward. Because ultimately, we want science to be a unified fabric, in my opinion. And so RFT sort of blends across some of these divides. And that doesn't mean it's a final answer. I mean, because it doesn't do that much with the underlying neurobiology. It doesn't do that much with cultural influences. A little bit with the cooperation, social primates, those things. So it's any bit of human complexity requires cooperation among the many human sciences, life sciences, in order to make progress. And so it's in that spirit that I wanted to speak with you, not in a spirit of having the answers, and but more in the spirit of maybe giving you some tools to seek the answers that are important to you.
Yes, thank you so much. That was amazing. And if you want to come back to tell us more about your new research, or send us by email. We will be happy to read it. So thank you very much for being here. You're really kind. And thank you, everybody, for organizing the talk. And do you want to say?
Can I say one little thing? There's
Yeah.
a group called the Association for Contextual Behavioral Science. It has a very large Brazilian chapter. It's people who do the kind of things I'm talking about. And it's not just psychologists and it's not just therapists, as many therapists. But if you want to connect with the kind of people who do this kind of work, go and look for the Association for Contextual Behavioral Science. And you'll find that even at your university there, you have colleagues, and certainly in your country, you have many, many, many colleagues that are very close by who'd be very interested in interacting with you.
Nice to know. Nice to know.
Nice to know. I will look for it, and thank you so much for everything.
Thank you, Professor. Thank you so much. So from here is good evening, good night, actually. So see you, and we'll end here our talk. Thank you so much.
Thank you. Bye-bye.
See you.
Tudo bem.
Boa noite, todo mundo. Até a próxima.